Hi everyone, my name is Frank Baudin and I want to talk to you today about MetalLB and EgressService L2 Advanced Traffic Steering within a Red Hat OpenShift context. A quick disclaimer that I invite you to pause on and read. The key takeaways are: I'm a Red Hat employee, but those materials are not Red Hat materials. They are educational material that should not be used as is in any production or mission critical context. With that said, we are going to look first at MetalLB L2 and how we are going to use specific route to connect to remote different CIDRs, and that with EgressService L2, you just need to have one default route per L2 network, connecting you to your default gateway in order to reach to any number of remote CIDRs. So here is the setup. So on the right, we have a typical worker node on OpenShift. We have a DC gateway and two remote sites. So we are going to have a first pod with a service. This service CIDR is not the same as the VLAN, the local VLAN CIDR. So usually you can pick the same CIDR as the VLAN. So it's more convenient for the configuration of your DC gateway, but as long as you put the proper route, it's going to work. And we are putting a second service, the second service going to the second VLAN. On those two networks, the green one and the red one, the dot one is the DC gateway. And what you need to do is, for each and every remote CIDR, you need to create a route. So here we have only one remote site per VLAN, but you could have 100 here and 100 here, so you would have 100 entries for VLAN 161 and 100 for VLAN 162. So here, in your node network configuration policy, you say, okay, for this destination, my next stop is my DC gateway via this VLAN, VLAN 161, and on VLAN 162, you do the same for 10.20.0/24 to be your remote CIDR. This is the only thing that you need to do. Now, as I said, how to manage many remote CIDR, how to update routes seamlessly, efficiently. So the first option is to regenerate a node network configuration every time you have a change in remote CIDR IPs or a change in policy. You can build automation for that. It's pretty easy. It can be done with Ansible or something else. It's easy technically, but what's going to trigger this kind of update, that's another story. And this is where you could use, as my preferred option, FRR Kubernetes and BGP routes. So instead of using static routes, you just peer on each and every VLAN to the DC gateway. You learn the routes for the remote sites. Your network is end-to-end BGP aware and nothing needs to be done. The routes are propagated. This is a documentation on how to use FRR Kubernetes on Red Hat OpenShift. And there is a third option that I'm going to present in next slide, which is to use EgressService in case you cannot deploy BGP in your network. So the documentation of EgressService is available, but is not documenting this simple L2 use case. EgressService is documented in the context of VRF and BGP, but it does not mean that it's not working with L2. It's just working with L2, as I'm going to explain and then demonstrate. So we have the same setup, same everything, except that this time we are going to associate for each and every service an EgressService object. In this EgressService object, you have the network here, which corresponds to a table number in the node network configuration. And this way, instead of having one route per remote CIDR, you have one route per local VLAN, and you say, okay, my default gateway 0.0.0/0 is my DC gateway, and I'm using table 10 corresponding to EgressService network object, okay? So this pod is going to hit this routing table because of this attribute in the EgressService, and the second pod is going to hit the table 20 below, same on the network 162. Very easy, quite straightforward. Let's demonstrate first MetalLB L2 and then EgressService L2. So this is my lab. I'm going to create these two pods, and I'm going to connect on router 10 with a red terminal, green for router 20, and blue for the DC gateway, and white for the worker node and the OpenShift console. So router 10, DC gateway, router 20, and the console. So let's start with the cluster version, so that's 4.19.0. Okay, so let's have a look at the network, at the NM state configuration of the node. So I've got first a basic interface, ENO2, so then I've got two VLANs. With this first CIDR, I've got a second VLAN on the same interface. So VLAN 162, second CIDR. And I've got two destination routes, one for 10.10, remote, which is router 10, and 10.20, which is going to be router 20. So this one via 162. So the packets are going from CAT to the DC gateway, and then are going to reach either router 10, either router 20. I'm showing you again the schema one last time. Okay, let's get to it. So let's create the network manager policy. Okay, then let's create the pods and the MetalLB configuration. So let's have a quick look at the MetalLB configuration. So I've got an L2 advertisement on ENO2 161 using the L2 161 IP address pool. And I've got this IP address pool right below. And as you can see, I'm going to use a .15, which is between 5 and 100, obviously. And I've got the same here for the second VLAN 162. And when it comes to the pod and the service, so I'm creating a pod named P161, which is going to run an HTTP server. And it has extra capabilities, so I can do some TCP dump, but that's not for this demonstration. I've got a service which is of type load balancer, and this is the IP, okay? So that's going to be 10.2.2.15 on HTTP 161, which is the VLAN 161. And I've got the same on 162, okay? This time 10.20.20.15, both 15. Okay, so they have been created. So let's have a look at the pod and the service. This pod and this pod. And I've got these two services, as you can see, the IP that I was talking about. So now, let's have a look at the logs of the first pod. We are going to TCP dump on the DC gateway. So the DC gateway is going to get the packet from the router 10 and forward them to the cluster. So let's connect. So on router 10, I'm going to use this source IP, and I'm going to connect to this IP on the port 8180. So let's do that. So I've got a log, and because I used a cluster external traffic policy, so I can see that the source IP address is the source IP address that I used, 10.0.0.1. And here you can see that every packet arriving on VLAN 164 is forwarded on VLAN 161 and vice versa. So because these two are connected via VLAN 164 and these two via VLAN 165. So let's have a look at 162, the logs of 162, okay. And okay, so this time packets arrive on VLAN 165. So the first packet is arriving here, 165, and forwarded to 162. That's my TCP scene, okay. and I've got the log. Okay, so it's working perfectly. We can have a look on router 10. So now I'm going to TCP dump here. So here I need to track now ICMP. And I'm going to ping from the pod, from this pod. So let's ping one packet. As you can see here, exec on this pod and ping one packet. And I receive one packet with the source IP address, which is the source IP of the node. Okay. So if I SSH and I look at the IP address, I've got a lot of IP address. And as you can see, I've got BRX, ENO2, and somewhere, okay, that's at the bottom, almost at the bottom, sorry about that, here. I've got 161, okay, the IP address is, as you can see, 143 on this network, and on the other network it's 43 as well. All right, so that was for MetalLB egress service. So now we are going to replace the egress, that was for MetalLB L2. So now let's have a look at an egress service. So first I need to clean up the configuration. I need to remove the NMC, the interface in NM state, because if not the IP, because this is the way NM state work. So let's check out the master node, and now let's create. So let's have a look at this one. So exactly the same as before, but this time I only have I've got a default route, and the table ID is 10 on 10, so that's the DC gateway here, and here it's going, and here on the VLAN 162, same, just one default address. So if we create, and we can have a look at, right now nothing's happened really on CAT, so you see that you have the usual IP addresses on the node, and here you can see the two connected routes. I could have done that earlier, that would have been better. And as you can see here, you have the default IP rules, this one being the one added when you switch OVNK to local gateway. So that's what you have. So now let's create the MetalLB egress service. So I create the same L2 advertisement, the same pod, but the difference is the egress service. So if we look at the egress service which is created, so the first one here, so you see that the network is 10, load balancer IP, and it's going to be on the VLAN 161. It has to be the same name as the service name, and I've got a second egress IP on network 20. So it has been created, and what's interesting to look at is, again, to look at the IP rules. So this time I've got two IP rules which have been added. So this is how egress service is working under the hood. So this is the pod IP that is going to host the service. Let's see, get pods. So as you can see, this is the pod IP here, and here this is the pod IP, and this is the service. Get. So this is how it's working under the hood. So you have the cluster IP here, so 127. And here it's going to be 202. So basically, any packet coming with this cluster IP or with the pod IP is going to hit the table 10 or 20. So this is how egress IP is capturing the traffic in the default namespace. So let's have a look at, again, so this pod. So I'm going to connect to this pod with the exact same command, and it's working. That's pretty cool. So here I'm going also to connect, and it's working as well. We can have a quick look at the logs. Nothing fancy here. And now I'm going to, so I was still on ICMP here, but anyway, the packets here were exactly the same, so no interest to look at them. But let's have a look at the ICMP. So this time I'm going to ping from P161, so I'm going to ping router 10. And this time, what's interesting, and I should have TCP done, but we're going to see the IP address here. So the destination IP is exactly the one that we want, but the source IP is the source IP of the egress service, of the service backed by the egress service. So that's the difference between MetalLB L2, because in the previous example here, we were seeing it's right above the node IP. Now we can do something a little different. So on my node, the default route, which is here, is going via BRX. So basically, if I try to ping from the pod this public IP, what you see here, I've got an echo request coming on VLAN 161, but there is no default gateway on VLAN 161. You need to exit via another route. So basically what it says is this is really the default route for the pod. So you're going to hit table 10 always for all of the pods with the service backed by egress service on the table 10, and the same for table 20. So you have to accept when you use egress service that all of your traffic is going to go through one VLAN. You cannot have a pod across two VLAN. It's going to be one VLAN only. So if we look back at this picture, pod 1 is always going to exit via VLAN 161 and pod 2 via 162, while when you don't have an egress service, depending here you have destination-based routing, so the pod can exit via this VLAN, eventually this VLAN, eventually this VLAN. But with egress service, this is not possible anymore because you have a specific routing table because of the egress service. So that concludes the presentation and the demonstration. Thank you for your attention.